So today we're going to learn, and you've already learned this, but I want to go over it because this is going to be really crucial to the next couple of units, what we're doing. And it's finding the horizontal and vertical components of a vector, okay? So the very first thing is, if this is my vector, let's call this V. Let me get a black pen. Okay, this is the vector we're looking at, the one we start with, okay? And it's going to have an angle that we rotate, and we always rotate from this positive x-axis, okay? So when I give this to you, I'm going to give you the length, the magnitude of this, and I'm also going to give you the angle, okay? So in this case, the angle's in the first quadrant, all right? And so we'd rotate, and this is what I'm going to call angle theta. It's always going to be the angle measured from the positive x-axis, okay? That's really, really important because we'll get the wrong answers if you don't do it that way, okay? So theta is always measured from the positive x-axis. Okay, and for simplicity, we're going to rotate counterclockwise. So the direction this arrow is going, so counterclockwise. So if we start right here, this could be considered angle of 0 degrees if we start right on the positive x-axis. As we rotate around, okay, this would be 90 degrees, and every one of these is going to be another 90 degrees. So if we're in here, if we go a little bit past and we know the angle we've passed north, we would take 90 degrees plus that angle, okay? Then this would be 180 degrees, okay? If we knew the angle made between our angle and the negative x-axis here, which is the line for west, okay, we would have to take 180 minus, and so on, okay? And this would be 270 degrees. And then as we come back around, this would be 360 degrees. So depending, we're going to either have to take the angle of the triangle we're finding, okay? And we're either going to have to add to the 90 or take away from the 180 or add to the 180 or take away from 270 or add to 270 or take away from 360, okay? All right, so the next thing is, let's talk about the components, okay? So this is the vertical component. It's the y component. So we say v sub y. Now, technically, I should be saying this. We should have a little arrow over this v, okay? I haven't been drawing that just to simplify things, but it really should be, okay? If you don't write it, it's not a big deal to me, okay? So right here, this is the horizontal component of this vector. So v sub x, okay? And so we know from this angle, because I'm going to give you the angle and I'm going to give you the hypotenuse, right? We know that sine, actually, whoops, I meant cosine. Cosine of angle theta, again, angle theta is measured from that positive x-axis, is equal to the adjacent leg, which is v sub x, over the resultant vector v sub r. That's going to be the vector I give you. Okay. So once again, I left off the arrows, right? Okay. So you can multiply both sides and you get the horizontal component v sub x is equal to v sub r cosine of angle theta. Okay. So we're going to take our magnitude of our vector and multiply it by cosine of that angle. All right. And hopefully I'm hoping this is easy, but I know some of you aren't in. This is probably easy if you're in honors math 3, probably not as easy if you're not in honors math 3. Okay. So I really want to help those of you who are struggling and don't quite understand this. Okay. So then this vertical component, okay, is, because this is the opposite leg and the hypotenuse, we would have sine of angle theta is equal to the opposite leg, which in this case is v sub y, over v sub r. Okay. And so multiplying both sides by v sub r, we'll find v sub y. So v sub y is equal to v sub r sine of angle theta. Really, really, I can't stress this enough. You gotta measure the angle from the positive x-axis. So I'm gonna start drawing my positive x-axis in green, okay? All right, so here we go. Find the horizontal and vertical components of the velocity vector, 35 meters per second, 40 degrees north of east. Okay, so this is the direction of rotation, and this is where we're gonna start. So this is the start. Okay, and this is the direction of rotation. So we're gonna rotate towards the north. Okay, so here we go. I'm gonna draw, actually I wanted to draw my positive x-axis right here. Okay. So this is north, this is south, this is west, and this is east. Okay, so we know the magnitude is 35 meters per second, okay? And so we know the rotation is 40 degrees north of east. So we're gonna start on east and we're gonna rotate 40 degrees towards the north. So that would put you up in here. Okay, so this is, I know the magnitude is 35 meters per second, and I know this angle right here because I rotated from the east, 40 degrees. Okay, so that means, all right, that my horizontal component V sub x would equal 35 meters per second times cosine of 40 degrees. And so we put that into our calculator, and we need to make sure we're in degree mode, okay? And we just type in 35 cosine 40. And we get, and let's round to 2 decimal places, okay? So 26.81. And that would be meters per second, right? Our vertical component, V sub y, is equal to 35 meters per second times sine of 40 degrees. So 35 sine 40 degrees, 22.49. Because it's a 7, that makes the 9 a 10, which makes the 4 a 5, 22.5. So 22.50 meters per second. I'd be fine if you just wrote 22.5. Okay, but you got to make sure you're in degree mode. All right, that was in the first quadrant, fairly simple, okay? And you won't be able to do this class if you can't do this, okay? So this is really important that you learn how to do this. That's why I'm going over it again, even though I went over it last semester, because it's really important. I want you guys to get it, okay? All right, so let's do another example. Okay, so I'm going to draw my positive x-axis. I'm going to draw it in green so you always see it, okay? And then here's my y-axis and my negative x-axis, okay? So again, this is north, this is south, this is west, and this is east. Okay, so this time we're going to draw our diagram, and it's going to be a vector that's 25 meters per second, and it's 20 degrees west of north. Okay, so west of north. So that means the start, we're going to start at the north, and we're going to rotate west. And we're going to rotate 20 degrees. So we're going to go 20 degrees, and we're going to rotate this way. And it's going to look something like this, where this is a 20-degree angle right here. All right. And I know the length of this is 25 meters per second. Okay. Now I'm going to call this angle, this 20-degree angle, alpha. So alpha, it's a little fishy, okay, is 20 degrees. That is not theta, because theta must be measured from the positive x-axis. So remember, this is from here to here is 90 degrees. So we got to go 20 more degrees. So my angle theta has to be 90 degrees plus the 20 degrees. for that full rotation. Okay, so theta winds up being 90 degrees plus 20 degrees is 110 degrees. So we have to get the right angle of rotation in order to get the right values for our trig functions. Okay, so once again, our v sub x is equal to the 25 meters per second cosine, not of the 20 degrees, but the 110 degrees. And we put that into our calculator. So 25 cosine 110, and we get negative 8.55. So that's negative 8.55 meters per second. All right. And that should make sense because we're going to have to get here and to do the head and tail method of adding vectors, we're going to have to go to the left and then we're going to have to go up. Okay. So my vertical component, which is v sub y, would be 25 meters per second sine of 110 degrees. So putting that into our calculator, 25 sine 110, and we get 23.49. Meters per second. Okay, so there's our both our horizontal component and our vertical component. Okay, and again, the angle theta has to be measured from the positive x-axis. For this next example, okay, we're doing the same thing, but this time it's the vector is going to be 70 meters per second, and it's 30 degrees south of west. Okay, so I'm going to draw my positive x-axis in green, and then my negative x-axis in a different color. Okay, so this is north, this is south, this is west, and this is east. Okay, so we need to go 30 degrees south of west. So we want to start at west and we want to rotate into the south. Okay, and we're going to rotate 30 degrees. So I'm going to go here and I'm going to rotate down from here 30 degrees. And there's the vector, okay? And I know it's 70 meters per second. I didn't write that on the last one. Okay, so my horizontal component is going to come out this way. And my vertical component is going to have to come down because we have to go head to tail, right? Head to tail. So this is going to be my v sub x, and this is my v sub y. Okay, and here's what's important. If you use 30 degrees, you are going to get the problem wrong. If you use, not because I want you to, okay, or not because I just say so, it's because 30 degrees is not the right angle. We have to, for trigonometry, the angles are always measured from the positive x-axis, okay? So we actually have to figure out what this angle is all the way to here, okay? So to rotate is 1/2 rotation. This is 180 degrees. Now, again, I'm going to use this alpha, okay? My angle alpha is 30 degrees. That's the angle of the triangle, okay? But I'm going to have to go 180 degrees, and then I'm going to have to go 30 more degrees to get the rotation. So actually, my angle theta is 180 degrees, and I need to go 30 degrees more than that because 180 degrees would stop it right on the negative x-axis right here. Okay, I got to go this little amount more, right? So this is 180 degrees plus 30 degrees. And so that makes theta, our angle, 210 degrees. That's the angle we need to use. Okay, I can't stress that enough with you guys, all right? It's starting to sound like I'm mad, but I'm not, all right? Okay, here we go. V sub x. So V sub x is equal to 70 meters per second cosine of 210 degrees. Okay, and putting that into our calculator, 70 cosine 210, and we get negative 60.62. Okay, and that makes sense because we're going to have to go to the left. We're going to have to go towards the west, and going towards west is negative. Okay, whoops, I put degrees. That is not a degree. Okay, it's actually meters per second. Okay, and then V sub y. V sub y is 70 meters per second sine of 210 degrees. Okay, so putting that in our calculator, 70 sine 210, and we get negative 35. So negative 35, that's exact, meters per second. If you take trigonometry, you're going to start to understand why some of them come out to be exact. Okay. All right. Hopefully this is like really, it's coming back and it's making sense. And I can't stress enough. If you use what happens is if you use the 30-degree angles, these both come out to be positive, and that's not correct. Okay. All right. So for this last one, we want to find the components. Okay. It's 40 meters per second. And this time it's 25 degrees south of east. So I'm going to draw my x-axis in green. Mrs. Ramming gave me that idea, guys. I was talking to her about this and how to break this up to make it simple for you guys. Okay. I was just running stuff by her. Okay. So 40 meters per second, 25 degrees south of east. So this is the start. We're going to start on the east and we're going to rotate south. Okay. So this is east. This is north. This is west, and this is south. And so we're going to start on the east. We're going to start at the east, and we're going to rotate south. So that means I'm going to rotate downwards, okay? And I'm going to rotate 25 degrees. So that would look like this. So this angle right here is 25 degrees. And so, and I know this is my vector, and I know this is 40 meters per second. This is going to all have to do with relative velocities that you're going to see when we start going in 2 dimensions too. Okay. So this is going to be my horizontal component, V sub x, and my vertical component is going to come down. So we should automatically, just by drawing this and looking at it, okay, our V sub x should come out to be positive and our V sub y should come out to be negative. Okay, just because of where it's located. All right, because going to the right or going east is positive and going down or south is negative. Okay, so what's our angle that we rotate? Well, okay, this alpha is 25 degrees, but that's not the angle of rotation. That's just the angle of our triangle. Okay. If we want to rotate, we got to rotate all the way to right here. Okay. Now, because I know this 25-degree angle, if I come all the way around, I know that that's a 360-degree rotation. Okay. But that would be too much rotation. So what I'm going to have to do is I'm going to have to back off 25 degrees. And that would be the angle that I rotate. So it's 360 minus 25 degrees. So theta is equal to 360 degrees minus 25 degrees. And that would be this angle of rotation, theta. Okay. And so that would give you 335 degrees. Okay. Which means V sub x, the velocity for the x component, would be 40 meters per second cosine of 335 degrees. Or put equals either way. So 40 cosine 335 degrees gives you 36.25. So this is 36.25 meters per second. To get our vertical component, v sub y, that would be 40 meters per second sine of 335 degrees. And putting that into our calculator, we get negative 16.90. Again, if you wrote negative 16.9, that'd be fine. All right, guys, we got to be able to do this. Okay. And then what I'm going to do Tuesday is we're going to go the reverse. So I give you the components and we have to find the magnitude and the angle. Okay. All right. So that's how we're going to do this. Okay. So I'm breaking it up into a couple days, and then next Thursday, we'll go back to adding vectors and relative velocities. Okay. All right, you guys, let's meet back on Zoom and we'll do maybe another example live. Okay.